Express 2 sine x plus 5 cos x in the form of r sine x plus alpha, where r is greater than 0 and alpha lies between 0 and 90 degrees. Give your value of alpha to the nearest 0.1 degree. Write down the maximum value of 2 sine x plus 5 cos x. Find the value of x in the interval of x between 0 and 360 degrees at which this maximum occurs, giving the value of x to the nearest 0.1 degree. So here's the question then in summary form. Let's have a look at it then. So part A. So let's use the compound angle formula then. So this left hand side 2 sine plus 5 cos x is equal to this formula here. This compound angle here. So it's r lots of sine A sine x cosine alpha plus r lots of cosine x sine alpha using the compound angle formula. Now let's equate sines and cosines. So let's equate sines first then. 2 is equal to sine x, there's r cos alpha lots of, aren't there? That's equation 1. And equate the cosines now. 5 is equal to, the cosines on the other side is r sine alpha. That's number 2. So that tells us then that r, if we square this and square this, we'll get r squared sine squared plus cos squared, which is r squared, is that squared plus that squared. So r squared is 2 squared plus 5 squared. But then we can just square root both sides, can't we? So it's root 29. 25 plus 4 is 29, so it's root 29. So that's r. Also, tan alpha then, 2 divided by 1, sine over cos is 5 over 2. So alpha is equal to then, shift tan. So shift tan, 2.5 or 5 over 2 equals, we're in degrees mode, and it's 68.19. To the nearest 0.1 degree would be 68.2 degrees. Okay, there's alpha, and we found it to the nearest 0.1 degree. So, that's part A done then. Part B. Write down the maximum value of this thing. Max value is, just have to write it down. So if we look at it, it's r sine. R is root 29 sine of something. And sine varies between 1 and minus 1, doesn't it? So we've got root 29 times the function, which varies between 1 and minus 1. So the maximum value it can have is root 29. So we can just write that down. So that's B part 1 then. And then it says, find the x values between 0 and 360, or one x value, where this value occurs. So here, part 2 then. So here, root 29 sine x plus alpha, which is 68.2, so we might as well put it in. 68.2 degrees is equal to root 29. That tells us then divide by root 29 both sides. That sine x plus 68.2 degrees equals 1. So let's draw a circle. We're solving between 0 and 360, right cast. Sine is positive here, sine is positive here and here, so draw 2 lines to the horizontal and mark off half of the angle. The associated acute angle to the horizontal, and write sine alpha equals 1. So that tells us that alpha, shift sine, will give us 90 degrees, won't it? So there's alpha, in this particular case here, for the associated acute angle. So x plus 68.2 is equal to 90 degrees. But when we work this x value out, it's going to produce a negative angle, and we're working in positive 0 to 360 domain. So if I just add a 360 here right at the outset, then that will make that a lot. Oh no, it's fine, sorry. 90 take 68 is still positive, isn't it? So that's equal to then. So it's even easier than I was trying to make it. 90 minus the 68.2 is 21.8 degrees.